So in order to make this work for more complicated data, we're going to need random weights, which I'm going to put in here, and we might also need bias neurons. Actually, the XOR problem is going to be solvable without using bias neurons if we have 4 hidden neurons, as we have in this case, because like 2 of those hidden neurons are going to be used like biases. But it's good to understand how biases work, and in some cases you actually have to use them, so might as well put them in. Weights. So layer 0 for I in range. So we're gonna do an operation here on the bias neuron as well. J in range. So all the neurons included in the bias neurons is 4 synapses. So we're going to create a random number here between -2 and 2. We haven't included random, so let's do that. I don't think we're going to need it here. And so why did I write -2 and 2? And if we take up a picture of the sigmoid function, we can see here that the sigmoid function is at its most active between like here, which is like -2 and 2. And if you initialize your values like somewhere in this region where it's moving a lot, that means that things are going to happen. And a usual mistake is that you initialize them to the totally like wrong values, like too large values, so that they end up here or here, and then it's going to be stuck from the beginning, and nothing's going to happen when it's learning. This is basically like the learning curve. So let's continue here, and then we're going to set the attribute. It's the weight with my weight, and then we'll do the same for the next layer. So now we're going to put a 5 here because we're going to use the bias neuron, and 1 and 2 and I and 0. So I just wanted to point out also that I didn't initialize these weights really close to 0, because if you do that, it's going to be harder for the network to do like labor division in the beginning and assign like different tasks to different neurons. So say that you have a weight over here, the network is gonna say to that neuron like, okay, you're gonna take care of like negative values or something like that, and the opposite over here. So it might be good to have this kind of spread out. And we're also gonna have to change a bunch of these loops, like put in 3 instead of 2 and 5 instead of 4 in a number of places to make this work. Yeah, I guess this should have been done with dynamical numbering, of course, but yeah, whatever. I can do that later. And we're also going to call the initialize weight. Oh yeah, this can be an S, I guess. So now we have random weights, and now I'm going to put in Q-line edits and these lines for the bias neurons. And yeah, there actually isn't a bias neuron here. They're only connected forwards to the next layer. So we're going to take that away. To begin with, we can comment away the background picture. And then I'm going to draw the lines. that is like done here. I'm actually just gonna copy paste in here the updated version. Because it's just like trial and error. It's no point in going through this. So I just put in some extra lines, basically. And then we're gonna do the line edits. So I'm gonna go down here. So bias between layer 0 and layer 1. So the coordinate of the bias, get coordinates, get neuron. Which neuron? We want the neuron from the first layer and on position 2, index 2, which is the third one. And we want to do stuff with the output. And it's going to be the bias output, so just put a B in front of out there. It's going to be a Q line edit. We're going to set the geometry of this. So we take the coordinates and yeah, just put in 25 there. Coordinates again. So now we're going to append this into this list, and the way we have it is that we have an index first of the Q-line edit, and then we're going to put in the actual Q-line edit after that. And then we're going to do stuff with the weights. So that's going to be a loop with 4 weights. Okay, so this is going to be the bias weight. That's going to be a Q push button, just like the other ones. We're going to set the geometry same way as before. You can just copy paste that. Yeah, so here we have this calculation of how to move them about, similar to how we did it before. And we can make them a bit wider. So now we put that button into the set of buttons. And now we're going to do the next one, like down here for the next layer. So that's going to be bias L1, L2. Get the coordinates of the bias. So we take it from the second set of neurons and position 4. So that's the 5th one. And we're gonna do this as well. We're gonna take that one, do this and this. This is going to be layer 1 here, and this is index 5, and then we're going to do the Q push button. Where was stack and just write it. So the weight I'm gonna set the geometry. Where did I do this? Oh, here. So it's not going to be the same here. Between 4 and 0. Okay, so now it looks like this, and we want to put in some values in here now. So we'll do that in update, line edits, and buttons here. It's gonna look kind of like this. Yes, it's the neuron number 2, and here it's going to be 2, 1, the way we did the output. And the output is only going to be 1. It's never going to change. It's like usually a constant, like 1 or -1. I'll make it to 1, so we don't need to round it. And then we're going to run this loop here. And 2 to I, it's going to be the index. The bias weight, we're going to set the text to the Q push button, and that is going to be an index 2 and I. And here we're going to round it like the other ones. Bias weight. Great, and then we're going to do the next one down here. Bias output is going to be get output. One, 4. Okay, that's the indexing is not very clever here, obviously. Take away the rounding. Q push button set text between layer 1 and layer 2, 4, 0, index 4, 0, and bias weight. These outputs should be 1. They're usually like -1 or 1. It's a constant, so we can put that in. When we build the neurons, this is going to be a 1 here. And now we're going to go through here to see what happens. When we forward propagate, we're basically not changing anything. We're just doing the same thing one more time. So we still do the weighted sum. We just like take in the bias weights as well. So that's it, and we do the same here, like we just add one more. and we don't change anything in here. And for backpropagation, for this backpropagation step between layer 2 and layer 1, we're going to put in self delta gradient L2 as the new bias delta weight value, and it's going to be index 4 here. That's the bias. And for this backpropagation, we are gonna do like pretty much the same thing as here, but we're not gonna use part 3 here. So basically, I'm gonna copy paste this whole part. So for I in range 0 to 4, we're gonna get a neuron from ij, and we only need one neuron actually. So part 1, we don't have part 3 here. Part 1 is exactly the same as before. Part 2 is exactly the same also. Just gonna change the indexing a bit, and delta weight is calculated by part 1 times part 2. So then we set this with these indexes here. Delta weight, and yeah, we're gonna do some batch delta weight change. So before that, I'm just gonna correct this. This is obviously wrong. This should be outside the loop. And I'm also gonna explain a bit about the bias neuron here. What just happened? And the bias neuron is kind of similar to the other neurons, but it's kind of less connected to the other stuff. Like it doesn't really care about what the inputs are here, and it doesn't really care what the stuff is happening in the previous layer here. And that can be a good thing. It makes the network more diverse and flexible. Works. And we're also gonna put in this batch functionality here. I'm gonna change this a bit first to delta weight. Since we're not in the loop anymore, we can write it like this instead. So we set the delta weight here, and now we're going to do the bias batch. It's going to be very similar to this one. So we get 40, the bias neuron, and we get batch delta weight. Calculate the new batch delta weight based on delta weight plus batch delta weight. We set 40 with the new batch delta weight. That makes sense. And then we have the same thing over here. So this we do inside the loop here with this batch delta. We can actually copy paste this whole thing. Bias batch. So we get from layer 0, layer 1 to I. Batch delta weight, and the new batch delta weight is going to be a delta weight plus batch delta weight. Set attribute layer 0, layer 1 to I. Batch delta weight, new batch delta weight. I'm going to do some more updates to the GUI now. We're going to put in a few more buttons. So we're going to have one button that runs 100 epochs with batch learning. and one that runs with pattern learning. And when we press either of these, a function is going to be activated. Run 100 epochs, and that one is going to take in a parameter delta weight for this case, and it's going to take in another parameter for the other case. So here we just type pattern instead. Actually, this is the opposite way around. Yeah, I'll change the order of this. It makes more sense. This one on top. Okay, I'm going to write this function now. So it's the update type, and I'm also going to name the controller so that there's no misunderstanding, because there is one type in the network as well. That one is actually named type right now, and I'm going to rename that to update type, because type is not a very good name to use as your own variables, because it's like used everywhere else. The variable that will be called update type. Or batch delta weight. And then we're going to run this 100 times. mnet.run epoch. Okay, so now I'm going to go into net and change this variable here. Type, it's very badly named. I'm going to change that to update type. Yeah, I already did this. Replace all. I hope it's not going to screw anything up. And then we can initialize the buttons to geometry and stuff. So this one will be right below the other one, and pattern. Oh, this should be self. And I'm also going to change the geometry of some other buttons. So these ones are the same height. Oh, I'm gonna move this one down, and also this one is gonna be moved. Also small fix to the print box, the Delta print box. We're also going to create a few more Q-line edits. So we're going to have one that is going to show how many epochs we've run. Oh. Q-line edit. And we're also going to have one that's going to show like the average MSC over the latest batch. It's going to be this one. And we're also going to have a text that shows when we reach the end of the data that we have to press load data one more time. So I'm going to initialize these in here at the bottom. And we're going to make the font a bit bigger so that we can see it clearly. And we're also going to set the geometry of the other ones. And then we're going to update them through the paint event. So that's going to be down here. So we set the text of the epochs with the epoch. We're going to have a variable that, yeah, we're going to create this counter soon. We're going to set this one with the one called batch MSC. Essentially this is always going to be a batch type calculation, but there's no reason to not show this when we do pattern learning as well, because it shows like how well the network is performing. And here we're going to do a another thing. We're going to print some text string in the GUI. So actually this is not how it's done when it's a label. So we just get the variable straight away, and then we set the text of this Q label. So so we reach the end of file, press twice to load from top. And then we do this if else statement here. So we print the string if this is true, if the end of data is reached. And we haven't created this Boolean variable yet. But if this Boolean variable is true, then we print this thing, else we print nothing. You'll get what this does later. So I'm not going to put in this variable in the net here. We'll initialize it to false. And we're also going to have a list of epoch MSEs so that we can calculate the average and show that. And we're also going to have the epoch counter. And that can be initialized to 0. So when we load the inputs, the epoch done can be printed. So we're going to print the list here. It's actually very good to see what the current MSCs are in the batch. And then we're going to write a function to update this value and also reset the batch delta weights. And here we should also update this this value to false, because there is more data, so we don't have to press again. So this function, let's write it. So so we're going to calculate the average of all the batch MSCs by taking the list and just like dividing it with the length. And then clear it after that. And then for all the synapses, we're gonna reset the batch delta weight values. And the same for the other set, for I in range 0 to 4. I0 and So I think I forgot to initialize a variable here. This variable. And something is wrong with this text box. Yeah, it should be a Q label instead of Q line edit. And yeah, it's also not the right dimensions. Yeah, here it should be 30 and not 300. So I'm gonna comment the picture now. I made some small improvements to it. Like I put in some text here, and I also redrew some of the arrows. So let's see when we load the inputs, many at a time. Oh. I think I know what's wrong. It's the in the network, when we calculate the errors, we have not updated the epoch MSEs. So it's trying to like make a division on an empty list. So now we have the values in there, and also in load inputs here, we actually need to move to the top of the file as well. So that's good to do. So this move to top of file is actually being done in two places right now. It's being done here too in the run epoch button, and when we press this, it's going to be done twice, so we have to take this away. And we should also set the flag here. So it always starts out as being false, and if there is data equals false, then we're going to check if the type is batch delta weight, and if so, we're going to update. And then we're also gonna, here, if we don't have any more data, we're gonna break this loop. The epoch is pretty much finished then, so break. I'm gonna take this away for now. And in the other case, we're just gonna do this, and can actually call this data row finished. And here we're also going to check if the update type is delta weight, and if that's the case, we're going to update here instead. So I realized that there's a better way of doing this. We shouldn't really have a update batch button, because the batch should be updated automatically when we press the load inputs button and fail to load inputs, and it's also going to interfere with these buttons. So I'm gonna move this if statement to the load inputs here, and it's actually better to put in this string here instead so that it's clear which type is being used. And in both cases we're gonna update these if we reach the end of the file, and then we're gonna remove the update batch button, this one. And we're gonna remove the initialization of it. The Y value here should be changed for a load inputs button. And I also fixed some redrawing in the paint program so that it looks like this again.